Good evening, I am Mr. Ish. We are looking here at a exponential function video. We've already presented one before this, but we're looking here at some additional points. Very quickly in terms of our review, we know this right here is our basic exponential function. It always goes here to 0, 1. In all respects, at any point on this curve, you can always draw a vertical line and it'll always cross always at one point. It will pass the vertical line test. Hence, in terms of a function, the exponential function is truly a function. In terms of the same function, let's look at it right over here, e to the x. A horizontal line will always cross it always at only one point. Hence, it has the one-to-one relationship with regards to the x and the y values, right? And it passes that horizontal line test based on what I'm showing you. So the exponential function will always have the ability for you to convert it into inverse. The horizontal line test very much has to do with something having an inverse. It's got nothing to do with the fact that it's a function. We already know something has a function, but in addition to that, if you wanted to know if that function had an inverse, you would do a horizontal line test. Over its entire domain from minus infinity to infinity, the exponential function has a horizontal line test success throughout that entire domain. Anywhere on this curve, you can easily do an inverse of this exponential function. F of x is equal to e to the x, and f of x is equal to, let's just say, e to the minus x. Determine the inverse of each of these functions. We have to find the inverse of both of these. Well, let's look at this one first. Y is equal to e to the x. Switch the letters around. This is the procedure for you to find the equation of the inverse. Switch the letters around. You get x is equal to e to the y. Use the properties of natural logs and bring the natural log. You'll have natural log x is equal to y ln e. Remember, you can break this down here using the properties of logs. And natural log e is always equal to 1. You solve over here, and then you know that y is equal to your new function, which is the inverse of the original function. Therefore, the inverse of this f of x equals e to the x is equal to the natural log. If y is equal to e to the x, the inverse of this is going to be natural log x. To remove any confusion, you can say f of x is equal to y is equal to e to the x. You can have inverse is equal to y, which is equal to natural log x. These are inverses of each other. This right here is the inverse of that. That's the first one done. Let's look at the other one, e to the minus x. Write it out clearly as you see it. Y is equal to e to the minus x. Switch the letters around. X is equal to e to the minus y. Solve for this in terms of the natural logs. Bring it here. Natural log x is equal to minus y. Natural log e. This is equal to 1. It goes away. Y is equal to minus natural log x. Right here. Here's your inverse. If f of x is equal to e to the minus x, then the inverse of this is equal to minus natural log x, and I've shown you here to be the case. So this question over here is done as well. Our last question for this one right here is this. We have to graph minus e to the minus x. If you saw the previous video, we know what the graph looks like. It's a double reflection of the original exponential, which looks like this, right? It's a double reflection of that. That graph will look like this, going here through 0, minus 1. It reflects this original e to the x across the x-axis, then reflects it again across the y-axis. So this right here is minus e to the minus x. Now we have to find the domain of this. Domain is easy. You're still looking from left to right. The domain here is going to be minus infinity to positive infinity. The range here, you're looking from down to up. You're coming up to minus infinity, but you're gonna go all the way up past this minus 1 and close as possible to this x-axis, which is always y equals 0, and that's where your range will end. Again, let's look here at the graph very quickly. This right here is e to the x. You reflect it across the x-axis. We're reflecting it across the x-axis, and then it becomes this. Then you reflect it again across the y-axis, and it becomes this right here. This right here is e to the x, this here is minus e to the x, this here is minus e to the minus x. And you've seen all of these reflections come through, and that's exactly how it is. Reflection across the x-axis, and then reflection across the y-axis, and there you have it. And thank you for watching this video. Have a good day.